Continuing to number 8. So we need to determine the area, circumference, and arc length. Okay, so area of a circle is equal to pi r squared. Circumference is equal to 2 pi r. And then the arc length is equal to d over 360 times 2 pi r. So the arc length, what we're doing is we're finding part of the circumference, remember? So that's where this proportion comes in. All right, so the first one, our radius is 5. So the area of that one is equal to 3.14 times 5 squared, which is 25. So 3.14 times 25, 78.5. Then to find the circumference, we're looking for 2 times 3.14 times 5. So 2 times 5 is 10. 10 times 3.14 is 31.4. Then the arc, I shouldn't just use A, I should just go ahead and say arc. That is equal to, our degrees are 40. And then we multiply that by 2 times pi times r. So once again, this becomes 31.4, but let's go ahead and do that out. 40 divided by 360 times 31.4. So the arc is 3.5 on that first one. All right, moving on to B. See, our radius is 7 on that one. So the area is equal to 3.14 times the radius squared, which is going to be 49. So 7 squared is 49. So 3.14 times 49, 153.86. So that's the area. The circumference is going to be 2 times 3.14 times 7. Oops. 7. That's funny. 2 times 3.14 times 7. That is 43.96. And then the arc, see, 100 degrees times 2, 3.14 times 7. We already know this to be that, so I can just substitute that in as I go. I just need the fraction part first. 100 over 360 times 43.96. That gives me 12.2. So the arc length on that one is 12.2. So now we go to C. let's see, our radius on that one is 9. So area is equal to 3.14 times 9 squared, which is going to be 81. So 81 times 3.14, 254.34. Okay, the circumference is 2 times pi times the radius, which is 9. So 18 times 3.14, 56.5. And now the arc. See, our degrees are 120. And then we multiply that by the circumference, which we know to be 56.5. So 120 over 360 times 56.5, 18.8. So the arc is 18.8. That's the arc length from A to B, the short distance. Ta-da! Okay, so we got some time here. Now, number 9. We're converting from radians to degrees and then from degrees to radians. So, remember it's pi over 180 is equal to the radians over the degrees. So, I'm going to use 3.14 over 180 is equal to, I'm given the radians, so I put the radians up here, 2.5, and then what I'm looking for in that first one is the degrees. So I cross multiply, so I've got 3.14 times the degrees is equal to 2.5 times 180 divided by 3.14. And that mess turns out to be 2.5 times 180 divided by 3.14. 143.3 degrees. Okay, now for the next one, we've got pi over 180 is equal to, and we're looking for the radians when given 270. Now in this case, I'm going to leave the pi in as pi, and I'm just going to leave it there in the final answer as well. Cross multiply, and you'll see. Let's see how this works out. So radians times 180 is equal to 270 times pi. Divide both sides by 180. Divide by 180. So now what I want to do is I just want to simplify this fraction right here. And I can knock off the 0 off from each, so it would be 27 over 18, but let's make sure that's in its simplest form. It is not. So the simplest form that this fraction can be put into is 3 over 2, and then I'm just going to tack on the pi. Now, if you change pi to 3.14 and then multiply it by this fraction, and then that's your answer, that's okay. But typically, not always, but typically when we have an angle that's in radian measurements, there's a pi on it. But it doesn't have to be that way. So like I said, if you converted that to 3.14 and then multiplied it by this fraction, then that's fine as well.